Today's video lesson is all about slope of graphs. Slope is the same thing as the words rate of change. This is the title for today's lesson. If you want to put this at the top of your notes, you will also have two notes pages that go along with this. They are both yellow. One says slope of a line at the top, and the second one has 8 different graphs on it.
Let's start off with the slope notes page that has the word slope of a line at the top. We are going to learn what slope even is. A second ago, we talked about slope also being called rate of change. Rate of change is the change in which a graph or situation changes. Pretty simple, pretty self-explanatory. Slope can mean rate of change. It can also, it's basically saying the steepness of a graph or a line. And whenever I say the steepness of a graph, a line, I'm kind of talking like the steepness of a mountain. You would normally say that if you were climbing a mountain that was really steep, it would be hard to climb. And if you were climbing a mountain that wasn't very steep, it would be more like a hill, which isn't very tough to climb. Steepness can also be a negative version. So as in, if I were climbing up a mountain, my line would go up. And you guessed it, if I were climbing down a mountain, my line would go down. So I want you to draw these two lines on your graphs. We're going to talk about different types of slope. There are technically 4 types of slope. Right now, we have our first type, which is the one that we were drawing up. And notice I put arrows on both sides. That's how lines work. Arrows on both sides means that the line goes on this way forever and ever, and this way forever and ever. If it didn't have 2 arrows, it would be a ray and not a line. So another important thing about slope is we read the graphs from left to right. Read the graph from left to right, just like we read a sentence. I read the sentence like this, read the graph from left to right, which that's not a complete sentence, by the way, but I am reading from left to right. We have to read our graph the same way, from left to right, just like that. So if I'm reading this line right here from left to right, that means I would be reading it going this way, which is up, which is why I call this a positive slope. Anytime you see a line that is going in the upwards way, that means that it is a positive slope. Anytime you see a line that's going down like this, remember we read from left to right. If we're reading from left to right, my line is going down. This is called a negative slope. And you were like, wait, what else is there besides negative or positive? There is actually called something right in between negative and positive slope. It is called a zero slope. If you are walking on a road and the road does not go up and it does not go down, it is not a steep hill, it is not an easy, you're going down and you're gonna catch momentum to going down. Anyways, it's neither one of those, it's just flat. It's zero, it's nothing. In between. And then there's one final slope, and it's something that we couldn't climb. This is called undefined. Now you're probably like, yes, I could climb that mountain if I was rock climbing. Haha, good one. But we're not rock climbing here. This is slope of a graph. Right here we have positive slopes, negative slopes, zero slopes, and no slope at all. It's just going straight up. It's called undefined. And we'll talk more about this one and why it's called undefined way later, okay? So let's go on and try to actually figure out the number version of the slope of these different lines. So first of all, right away, I can tell that this line right here, since I'm reading from left to right, is going to have a positive answer because I know that it is a positive slope. This one, even though it's really steep negatively, I can tell that it's going down because if I were reading from left to right like this, and I would be kind of going here and going down, all right? Left to right, I can see that this is going down. Even though it has an arrow going up, I have to read from left to right. Okay, the next thing we do for slope is to find some coordinates along the line. Remember, coordinates are where the line passes through the graph, through the little crosshairs like this, like a target almost. It passes through perfectly. So luckily for us, they gave us some dots that it passes through perfectly. And actually, here's one more dot way over here that this line passes through perfectly. The cool thing about slope is you can choose whichever ones of these dots you need. All you need is 2. And if you might remember from previous years, and if not, that is okay, we say slope is rise over run. Rise over run is something you're going to hear me say so many times, it's insane. But it is true, rise over run, which means that I'm trying to see how far I'm rising and running along this line. I can't count perfectly 1, 2, 3, 4, because those aren't perfect boxes. They're not units, the correct units that I need to be counting in. So I have to use this method called rise over run. Here's what I do. From what dot to the next, it doesn't matter if I use these 2 dots or these 2 dots, I am going to count how much it goes up and over. So if I were using the 2 dots that they gave me originally, I would count how much I was going up this way and over this way. So I would count 1, 2 going up. So I'll just put a little bitty rise over run here. 2 going up, and 1, 2, 3, 4 going to the side. That is why I call it a rise and a run, because I am rising, then running. Make sense? So you rise 2, you run 4. This is our slope answer. However, what I need you guys to get in the habit of is reducing this fraction, not to decimal form, just reducing. 2 over 4 does create 1/2 in the calculator. If I were calculating this, give me just a second. Excuse me. Okay, if I were calculating 2 over 4, I would put 2 divided by 4. And if I press enter, it reduces the fraction for me. It does not put it in decimal form. If I wanted it in decimal form, I would press control enter, but I don't. I just want a reduced fraction. So actually the answer is not 2 over 4, it is 1/2. Okay? 1/2 is our slope. So one more thing, not one more thing, but something else that's really important about doing the slope of a line is you have to do some important things. Yes, I did say we rise and we run, but I need you to know that we rise first. Always rise first and run to the right. Those are important things to know. We always rise first and then we run, and we always run to the right. If you find yourself running this way to count your run, you are doing it wrong. You have to run to the right. Here's how you make sure that you always run to the right. Remember that I said we read graphs from left to right, like this? Start on your left when you are working a graph and finding slopes. So my leftmost point would be this one right there. Okay, I will start there and I will rise and run. You might notice that we can't really rise and run to the right to find another point. That's because this line is negative. If I rise, which is technically going down, and running, I would only run over once. That is the only one that works to get from one point to the next. So luckily for us, again, they drew the dots for us. Remember, you only need two dots, which was nice that they made them for us. We got to figure out how much it is rising. It's going 1, 2, 3, 4. You might have noticed that I said rise for something that's going down. So we technically need to call this rise a -4. We said it was going down 4, 1, 2, 3, 4, down 4, and it's running just one little square. So -4 over 1. Again, we reduce the fraction. So -4 divided by 1, or -4 over 1, just simplifies down to just plain -4. All right, I'm gonna go a little bit quicker now. So determining the slope of these lines down here, if this line were to have continued, there would have been another dot right about here. But just so you know, they gave us some dots for us. That was really nice of them. We don't have to find the dots. So let's try our rise and run. Right off the bat, I noticed that this slope is going down if I'm reading from left to right. So if my answer is not negative at the end, I did something wrong. Rise is first, and then it is run. We always run to the right, and in order to run to the right, I have to start on the left. So I'm not going to rise and run because I'm not going up. This is not a positive slope, it's a negative slope, which means I'm probably going to be going down. Down 1, 2, 3, 4. So I'm going to call this -4. And running to the right, 1, 2, 3. And I did go to the right, which is great. -4 over 3 does not reduce. So if you ever get a fraction and you put -4 divided by 3, or -4 over 3 as a fraction, and you press enter and it gives you the same fraction, that means it's already reduced as far as it can go, which is your answer. All right, let's do the next one. You might notice that this one looks a little funky. It doesn't really go up, it doesn't really go down. That is because this slope right here is a 0 slope. You can actually put the number 0. I'm just gonna put the actual word 0 so you don't get it confused with an O. I could have looked at my little key up here and noticed that this was a 0 slope. It is flat. It does not go up or down. It's in the middle. It is 0. If you wanted to know, and if you wanted to actually calculate it, they still gave you 2 dots. You are not rising any, so I'm gonna just write down the rise over run. You need to write down rise over run until you get really good at this, by the way. I'm not rising any to get to my next dot. So I'm gonna put a 0, and then I am running 3. 1, 2, 3. So let's figure out what 0 over 3 is in our calculator. I bet you can figure it out in your head. 0 divided by 3. It's 0. 0 over 3 is 0. So our slope is 0, even though we already knew. All right, let's move on to the next set of notes, which is this one. I am only going to do a couple of these with you, and then you are going to do the rest before math workshop. So the first one I want you to see is something interesting. It is going straight up and down. If we use our little notes from earlier, this is called an undefined slope. So if you just look at it and know that it is going straight up and down, it's called undefined. That is perfectly fine with me. Another little trick to this, in case you would like to have it, is 0 slopes. It's just a trick, remember. 0 slopes create a Z. You could create a Z. Undefined slopes, you can create a U. You can't really switch the letters and it works, so that's just kind of a little trick to help you out. Here's the mathematical version of why this is undefined. If I were doing rise over run for this graph, I would be rising from the dots that it said, which is up 1, and I'm running none. It does not go to side, so I do 1 over 0. 1 over 0 in my calculator, 1 divided by 0, literally says the words undefined. It says undef, but it stands for undefined. That's because you cannot divide anything by 0. It is impossible. All right, let's try a couple more. I'm going to try this one over here for you. I noticed that they give me 2 dots. Here's something else that I noticed. I can find my own. It is a coordinate right up there. I kind of can start seeing a little pattern happening. And that's actually what slope is. You're really finding the pattern, the rate at which this line is changing. This is a positive slope, so I will be going up in this slope. I do need to write over to my side, rise and run. Remember, we always rise first and we run to the right. So if I am rising first and I'm reading my graph from left to right, I would start at this point here and run. Here's the nice thing about slope is as long as you find some points, all you need is 2. If your first vision was these 2 points here and you rise and run and you count how much you're going up and over, you will technically get the same answer as you would if you were rising and running here. Here's how. If I were rising from this dot to this dot, I would be going up 1, 2, 3, like that. So my rise would be 3, my run would be 1, 2, 3. 3 over 3 reduces down to just 1, 3 divided by 3. If I chose to use these 2 dots here, I would be going up 1, 2, 3, 4, 5, 6. Notice I'm only going up as far as I need to get to that dot. And then I go over 1, 2, 3, 4, 5, 6. I use these little puffy cloud things to show that I'm counting. You don't have to do that if you just want to draw a straight arrow kind of going up like that and over like that to get to the line. Remember, you make a perfect corner. You do not go up any further than you need to and then come back down. Do not do that. That is not how you do slope. But I did say that I went up 6 and over 6. 6 divided by 6 equals 1. Same slope. Here's something even more interesting. If I look really closely, this line is going up, over, up, over, up, over. I actually have a ton of coordinates all the way down my line. Perfect coordinates if you look really closely. It's kind of hard to see now because I put a marker over this, but these are all perfect coordinates. So our slope, if I looked at it this way, was 1 over 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. 1 over 1 is 1. That's my slope. So either way you do this, that's what you're going to get. Okay, I'm going to do one more. It is this one here. I can tell that this graph is going to have a negative answer. I'm not going to rise. I'm going to go down. I can tell because if I were reading this graph from left to right, this is a negative slope. It's going down. I would have been walking down the hill. This is positive because I would have been walking up the hill. All right, let's try this real quick. So here are my 2 dots. They do give them to me. Remember, if they didn't, I would have to look for the spot along the graph that the line crosses perfectly through the coordinates. So remember, I'm not going up and over. I'm going to have to go down and over. You make a perfect little right corner like a stair step, kind of like we were making stair steps along this one. Don't go any further or it won't work. So we're going to go down 1, 2, 3, 4, 5, over 1, 2. I said we were going down 5, so I'm just going to put a little negative 5 out here to the side and over 2. And if I had wrote my rise over run out to the side, my rise is a negative 5, my run is 2, and actually that does not reduce right there. Negative 5 over 2 is your answer. That is it for my notes.